Your electricity bill is lying to you, not the numbers, the idea behind it. The idea that you need expensive equipment just to survive summer. What if the ground under your feet has been offering you free cooling for thousands of years? And what if powerful companies have spent decades making sure you never find out? This is the $2 Fix channel, and today we're going underground. In this video, I'm going to show you an ancient cooling system that civilizations used thousands of years before electricity was even invented. It still works today. It costs almost nothing to run. But more importantly, I'm going to show you why certain states and billion-dollar HVAC companies don't want you building one. Stay with me. This gets good. If you're new here, this channel is about real fixes that save real money. No fluff, no sponsored garbage. Hit subscribe so you never miss a trick the big guys don't want you knowing. Let's talk about your air conditioner for a second. That machine sitting outside your house, it is one of the most expensive things you own. Not to buy, to run. The average American household spends over $500 a year just on cooling. In hot states like Texas, Arizona, or Florida, that number can hit $1,000 or more every single year. And it only gets worse. Summers are hotter now. Electricity prices keep climbing. And HVAC companies, they love it. Because every time you crank that AC, you're putting money directly into their pocket. Here's what nobody tells you, though. Your AC doesn't actually make cool air. It takes heat from inside your house and dumps it outside. It fights nature. And fighting nature costs energy. A lot of energy. Now, what if, instead of fighting nature, you just use nature? What if the ground itself could cool your home? Sounds too simple, right? That's exactly what they want you to think. Here's something that will blow your mind. Over 3,000 years ago, people in ancient Persia, modern-day Iran, built houses that stayed cool in desert heat. No electricity, no refrigerant, no compressor. They built two things. First, wind catchers. These were tall towers on top of houses that caught wind and directed it downward into the building. But that alone wasn't enough, so they combined it with something underground. Second, the connet system. Connets were long underground tunnels carved through the earth to move water. Air traveling through these tunnels got cooled by the surrounding soil before it entered the house. Desert temperatures outside? 45 degrees Celsius. That's over 110 Fahrenheit. Inside those houses? Cool, comfortable, almost unbelievable. And they weren't the only ones. The Romans buried water channels under their floors for temperature control. Medieval builders in North Africa and the Middle East used underground air passages in palaces and mosques. Even in India, ancient stepwells, called vav, created natural cooling zones that people used to escape the heat. These weren't accidents, these were engineered solutions. Smart, simple, and almost free to operate. So the question is, why did we forget all of this? Okay, here comes the science part. But I promise, it's simple. You ready? Dig down about 6 to 10 feet below the surface of the earth. Go ahead, in your mind. What's the temperature down there? It doesn't matter if it's winter or summer. It doesn't matter if it's 105 degrees outside or minus 10. The ground stays at a nearly constant temperature. In most parts of the United States, that's somewhere between 50 and 60 degrees Fahrenheit, all year, every year. The Earth is basically a giant thermal battery. It absorbs heat slowly and releases it slowly. The surface swings wildly, hot in summer, cold in winter. But just a few feet down, stable, calm, consistent. Now here's the magic. Imagine you take a long pipe. You bury it underground. You run it from outside your house, deep into the earth, and then bring it back up inside. Then you put a small fan at one end. Hot summer air enters the pipe. That air travels through the pipe. The pipe is surrounded by cool earth. The earth pulls the heat out of the air. By the time that air reaches the other end, inside your house, it's been cooled. Naturally, passively, for almost zero cost. That's it. That is the entire system. No compressor, no refrigerant, no crazy energy bills. Just air, pipe, earth, and physics doing exactly what it's supposed to do. So does anyone actually use this today? Yes, and they have a name for it. Earth tubes, also called earth air heat exchangers, or EAHE for short. And this is not some fringe experiment. Real homes, real buildings, real results. In Europe, especially Germany, Austria, and Switzerland, earth tubes have been used in energy-efficient home designs since the 1970s and 80s. The famous passive house movement, which builds homes that need almost zero energy for heating and cooling, often includes earth tubes as part of the design. There are schools in Germany cooled almost entirely by earth tubes. Commercial buildings in Switzerland have cut their HVAC energy use by 50% or more with this system. In the United States, some off-grid builders and permaculture designers have been quietly using earth tubes for years. There are homeowners in New Mexico, Montana, and North Carolina who report summer indoor temperatures staying around 68 to 72 degrees. while outside temps hit 95 or above. And their cooling cost? The electricity for a small fan. We're talking a few dollars a month, not hundreds, not thousands, a few dollars. One homeowner in Arizona documented his earth tube system online. He buried 150 feet of pipe at 8 feet deep. His summer cooling bill dropped by over 80%. So yes, this works. It works today. Which makes what I'm about to tell you even more frustrating. Let's count the wins here because there are a lot. Benefit number 1, almost free cooling. Once the system is installed, running costs are almost nothing. A small inline fan uses maybe 30 to 50 watts. That's less than a light bulb. Compare that to a central AC unit that pulls 3,000 to 5,000 watts every hour it runs. The savings are massive. Benefit number 2, it works in both seasons. In summer, the earth cools the incoming air. In winter, the earth pre-warms the cold outside air before it enters your home. One system, 2 benefits, 0 fuel. Benefit number 3, improved air quality. When air passes through properly built earth tubes, the soil can filter dust and some pollutants. Some designs include moisture management that also helps with humidity control. Benefit number 4, no moving parts, low maintenance. There's no compressor to break down, no refrigerant to leak, no expensive service calls every spring, just a pipe, some soil, and a fan. Benefit number 5, it scales. Small cabin, works. Full family home, works. Multi-room system with multiple pipes, absolutely works. You can go as big or as small as your budget and property allow. So why isn't everyone doing this? Now we get to the interesting part. Here's where the story gets a little dark. Building codes in the United States are incredibly strict about what systems can be used to condition indoor air. And right now, earth tubes sit in a legal gray zone in many states. In some places, they're not recognized at all. You can't get a permit for them. Inspectors don't know how to evaluate them. Insurance companies won't cover homes that use them. Banks sometimes won't issue mortgages on homes with non-standard HVAC systems. So even if you want to build one, the system makes it very hard. Now, is this all just red tape and slow bureaucracy? Maybe some of it. But think about who benefits from the current system. The HVAC industry in America is worth over $17 billion a year. That's billion. With a B, they sell you equipment. They sell you installation. They sell you maintenance contracts. They sell you repairs. Every year, on repeat. If earth tubes became mainstream, that revenue stream doesn't dry up overnight, but it gets seriously threatened. Now, I'm not saying there's a secret meeting where HVAC executives decided to suppress this technology. It doesn't need to be that dramatic. All it takes is a powerful industry that lobbies for specific building code standards, funds the research that validates their own products, and quietly keeps alternatives out of the mainstream conversation. That's not a conspiracy. That's just business. Cinema and homeowners like you pay the price every summer. But here's the thing. You can still do something about it. And I'm going to show you how. Because here's what nobody tells you about building one of these systems yourself. The actual cost might surprise you, not in a bad way. All right, let's get practical. If you want to explore earth tubes for your own home, here's what you need to know. First, check your local codes. I know, boring, but important. Before you dig anything, call your local building department and ask about ventilation systems that use underground air preconditioning. Some counties are fine with it if it's considered a supplemental system rather than a primary HVAC replacement. Others are more strict. Know your rules before you start. Now, the system itself. Step 1. Choose your pipe. Most earth tube builders use rigid PVC or HDPE pipe. HDPE, high-density polyethylene, is actually preferred by many experts because it's more moisture-resistant and durable underground. The diameter matters. 6-inch pipe is common for residential systems. Bigger diameter means more airflow, but more cost. Step 2. Length and depth. This is critical. Short pipes don't work. The air needs enough contact time with the surrounding earth to actually cool down. Most successful residential systems use between 100 and 200 feet of pipe total. Depth should be at least 6 feet, ideally 8 to 10 feet. That's where the earth temperature becomes truly stable. Step 3. Slope your pipe. Very important. Condensation happens inside earth tubes. When warm air meets cool pipe walls, moisture forms. If your pipe is perfectly flat, that water pools and can cause mold or bacterial growth inside the pipe. Slope your pipe slightly, full about 1 to 2%, toward a drainage point. Some designs include a simple condensate drain at the lowest point. This keeps the interior dry and clean. Step 4. Entry and exit points. The intake end, where outside air enters, should be positioned away from pollution sources, not near garbage bins, not near car exhaust. Some builders use a small intake box with a filter at the surface to keep insects and debris out. The output end should come up inside the home in a central location. A small basement connection point is ideal if you have one. Step 5. The fan. You don't need a big fan. A small inline duct fan, the kind used for bathroom ventilation, is often enough for a single room or small home system. Look for something rated around 100 to 200 cubic feet per minute. These fans run on as little as 15 to 30 watts. Connect it to a simple timer or thermostat, so it only runs when needed. Step 6. Materials cost. Here's the rough math for a basic 150-foot system. HDPE pipe, 6-inch diameter, approximately $200 to $400 depending on your region. Fittings, connectors, and drainage hardware, $50 to $100. Inline fan, $30 to $80. Trenching, if you rent a trencher yourself, $100 to $200 for a day, or hire it out for $300 to $600 depending on soil and location. Total DIY cost, somewhere between $400 and $800 for a basic system. Compare that to a new central AC unit, $3,000 to $7,000 installed, with no ongoing fuel cost. Step 7. Potential challenges. Radon is a real concern in some regions. If your area has high radon levels in the soil, pulling air through the ground can introduce radon into your home. Get a radon test before you build and research mitigation strategies if needed. Also, clay soils hold moisture differently than sandy soils. This affects condensation behavior inside your pipes. Do your soil research for your specific location. And again, in humid climates, moisture management inside the pipe becomes even more important. Design your drainage solution carefully. You're not alone in this. There's a growing community of off-grid builders, permaculture designers, and energy-independent homeowners who have been building earth tube systems quietly for years. Online forums like Reddit's R Off-Grid and R Permaculture have detailed build logs from real people. YouTube channels dedicated to natural building often cover earth tubes with real footage of functioning systems. There are even a handful of small engineering firms in the US and Europe that specialize in designing earth air heat exchangers for residential projects. The knowledge is out there. The physics works, the math works, the results are documented. What doesn't work is waiting for the mainstream HVAC industry to hand you this option. That's never going to happen. But you don't need their permission. Here's the truth that I want you to walk away with today. Cooling your home does not have to be expensive. It never had to be. Ancient Persian engineers figured this out in the desert with no computers, no contractors, no electricity. They used the earth. And it worked for thousands of years. Modern earth tube systems are cleaner, better designed, more efficient. And the only thing standing between you and almost free cooling is a little digging and a little courage. Yes, building codes are an obstacle in some areas. Yes, the system requires thought and planning. Yes, it's not for every climate or every property. But for many of you watching this right now, this is real. This is buildable. This is yours. So here's what I want you to do. First, drop a comment below and tell me, what's your biggest summer electricity bill? Let's make that number embarrassing together. Second, share this video with one person who complains about their AC bill, because they need to see this. Third, if you're seriously considering building your own system, start with your soil. Get a radon test, check your local codes, sketch your layout. The $2 Fix community is here if you have questions. And if you want to see a full step-by-step build series on an actual earth tube installation, comment dig deep below, and if enough of you want it, we'll make it happen. This channel exists because everyday people deserve real solutions. Not upsells, not subscriptions, not service contracts, real solutions. I'm glad you're here. Hit subscribe. I'll see you in the next one.